Well, hello to all my friends and students at the Cisco Learning Network. Anthony Sequeira here with Stormwind.com, and I'm so thrilled that you are joining me for part 2 in our 3-part series on IPv6, specifically targeted at our CCNA students. Yeah, what do we really need to know about IPv6 at the CCNA level? Well, in this second part, we're going to focus on those IPv6 addresses. Yes, for sure, this is an area of particular focus that we want to be aware of. Now, in the last video, let's just review, we had an IPv4 address at 32 bits in length. We can conveniently represent these 32 bits in what we call dotted decimal notation. 8 bits in the first, what we call octet, and then we have 3 more octets for a total of 4 octets that represent those 32 bits. In the IPv6 world, as we discussed last time, we have a substantially longer address, 128 bits in length. What's funny is it doesn't seem all that vastly longer, but what happens with exponential mathematics is that when you lengthen it that much, the number of possible addresses, it becomes absolutely amazing. We talked about last time how you can represent this. I mean, there is literally going to be billions of addresses for every square inch of the planet. I mean, it's amazing how big the address space becomes when you move it from 32 bits to 128 bits. Now, something that we need to be aware of is the dotted decimal notation for address representation is no longer going to make sense when the address is 128 bits in length. So what do we have? We have hexadecimal that is used to represent the address. I think this is going to warrant a review on hex, and we'll do that in a moment. But notice it's going to be a big long address even when written in hex, and we have our hexadecimal digits here, our hexadecimal characters, and we're going to have 4 of those, and then we separate 4 of them with a colon. Each of these hexadecimal characters represents how many bits? Each represents 4 bits. So sure enough, what we have here is we have 8 fields. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8. 8 fields, each with 4 characters inside representing 4 bits. So we have 8 16-bit fields in the IPv6 address. Now, it might be some time, it might be a real long time, it might be never since you have thought about hexadecimal. So let's just review how hexadecimal works quickly before we go any further in this video. So if we go on a review of hex, we recall that hex is going to be representing 16 different characters. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then it has the letters A, B, C, D, E, and F. What is this equivalent to in decimal? Well, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Notice it's all just 1 for 1, the representation, and then 10 is A, 11 is B, 12 is C, 13 is D, 14 is E, and 15 in decimal is the F. Now think about it, you could work this out in a binary representation. And to help us over here, I have a little conversion chart for just 4 bits because that's all we're working with in the hex. So 0 would be 0, 0, 0, 0, of course, in the binary bits. 1 would be 0, 0, 0, 1. We turn on the bit in that 1 position to give us the value of 1. 2 would be 0, 0, 1, 0, turning on that 2-bit position. How about 3? 0, 0, 1, 1. We won't complete this exercise, but you see how easy it is. Let's jump down here to A, right, which has a decimal value of 10. That would be turning on the 8-bit, and the 2-bit. So we would have 1010 in binary for the hexadecimal character of A, which we know translates to 10 in decimal. So obviously this is an important exercise, and it demonstrates for us exactly what in binary these hexadecimal characters represent. Now, it turns out that even in hex, as we saw when we looked at an IPv6 address, it's pretty long and ugly still, even with this very efficient hexadecimal representation. Well, I've got great news for you, everyone. There's going to be 3 kind of tricks that we can use to really help us when it comes to IPv6 address representation. It's very important that you know this from a CCNA level. First trick number 1, and this is just a nice convenience for us, the hexadecimal is not case sensitive. So we don't have to worry about like uppercase A versus lowercase a in the IPv6 address. The operating system for Cisco just doesn't care. Trick number 2 is the fact that leading zeros in any of the field are optional. So we can trim out any leading zeros that we might find in fields, right? So we could trim that one out. We could trim these 3 out, no problem. Those leading zeros are optional. The third trick, and this one is really cool, anytime you have a whole bunch of fields that contain zeros, you can represent that as colon. And we can do that exactly once in an address. So let's go to the command line of an actual Cisco router now, and let's try these 3 steps. Let's prove this at a Cisco device and make sure we can represent these IPv6 addresses nice and succinctly. So here we are at a completely default router. This router, all I did was give it a host name. I put in the logging synchronous command, so there's absolutely nothing up my sleeve. Or as my dear friend here at the Cisco Learning Network, Keith Barker, would say, my hands are attached to my arms. Yeah, there's nothing crazy going on here. Watch this. If I do a show IPv6 interface brief, I gotta spell it right. We see that there is absolutely no IPv6 addressing on this device. If I do show IP interface brief, there is no IPv4 addressing anywhere on this device. Great, so let's practice with this address representation and let's see if it works just like we said it did. Let's see if we can do these shortcuts. First, we'll go ahead and we'll put the address in longhand. Notice that if you have the correct operating system on your router, IPv6 is ready to go on the device. So I'm going to no shut this fast Ethernet 0/0 interface, and then I'm going to say IPv6 address, and we can start putting in the address. Look at that. So nothing required at all out of the ordinary to start putting your IPv6 addresses onto this device. So let's try it longhand, shall we? So I'll say 2031:00:130F. I'm doing the example that we looked at a moment ago. 0000:09C0. Let me mix the case. You can see we just mixed the case there to make sure that works. 876 capital A :130 lowercase b. Now we'll go ahead and put in the subnet mask, and it's a slash notation that we use with IPv6. We'll have a 64-bit subnet mask, which is standard. I hit enter, and it took it. Let's do show IPv6 interface brief, and we can see there it is. And notice what Cisco did. Cisco said, Anthony, there's some shortcuts we can use in the address representation. And they went and took advantage of those shortcuts, didn't they? Yeah, they trimmed off leading zeros. So we can see in this field, all the leading zeros were trimmed off and we are left with just a 0. And then there were those 2 fields that we had of just zeros, and it said we're going to once in the address represent that as colon. Look at that. It took our mixed case, and Cisco said, we prefer uppercase, Anthony. So they went in and they took all of our lowercase hexadecimal characters and they converted those into uppercase. And there you have it. So we got a proof here at the command line of this address shortcuts, of these 3 tips. And what were those 3 tips or tricks that we can do with V6 addresses? Well, to review, they were, number 1, case doesn't matter in those hexadecimal letters. Number 2, we can go ahead and trim off leading zeros in every single field. And number 3, if you're stuck with long sections of zeros, so maybe you have 3 or 4 of them in a row, those sections of the V6 address that have all zeros, once in the address and only once, you can do a colon to represent all of those zeros. Great stuff, obviously. Now, in an IPv4 world, one of the things that really annoy us are broadcasts. Yeah, I suppose it's that way in life, right? When we get junk mail, we get annoyed by that junk mail, especially if it has absolutely nothing to do with us. It's like when I get advertisements about manicures and pedicures. My toenails and fingernails are absolutely repulsive, and I like it that way, thank you very much. So that junk mail, that broadcast that goes to me is something that's really annoying. Broadcasts so annoy us in a V4 world that they actually go away in our V6 world. That's right, broadcasts are completely eliminated in V6. You see, we have unicast addresses. That's great, just like in V4, whenever we want to send traffic to one single system. We have multicast addresses that will send traffic to a group of systems, right? Now, that multicast capability right there is why we can eliminate broadcasts in IPv6. You see, if you want to do the equivalent of a broadcast in IPv6, you just send the data to the all nodes multicast address. Sure, so the trick to broadcast elimination in V6 is that there is an all nodes multicast address that devices participate in. Let's make sure this is real life. Let's make sure this is the truth, right? So what we'll do is on that device we were configuring, I'll say show IPv6 interface FA0/0. And we can see that this device has joined a particular group address. And the multicast address that it's joined is the all nodes multicast address. And by the way, we get a nice little review here of the shortcuts we can take with the V6 address representation. So sure enough, when we put IPv6 on this interface, this device joined the all nodes multicast group. And that's awesome because it means we don't have to do any broadcasting. We can use that group in order to send information to everyone. Now, there is another type of IPv6 address, and that's called the Anycast address. What you do with Anycast is you take the exact same IPv6 address, the identical address, and you assign it to multiple machines in V6. Now, when your routers get traffic for that address, they'll pick which device they're actually going to send that traffic to. What a neat way to kind of load balance, to load share across devices. And that's what an IPv6 Anycast is all about. Pretty cool. So unicast, multicast, and anycast in v6, no longer a need for the broadcast in that v6 environment. Now there's one last type of address that I want to share with you and discuss, and then we'll talk about how these addresses can get configured on our devices. The other address that's really important for you to know about as a CCNA is the link local address. This gets created automagically on your IPv6 device, and you can recognize it easily because it starts FE80. Yeah, FE80. What is this address all about? Well, look at its name. The address is named the link local address. So what do you think its job is? Whoever named it did a great job. Its job is to communicate on just the local link. This enables nodes on a shared link to be able to communicate the minute that IPv6 is enabled on that particular device, on that particular interface. Let's check this at the command line to make sure it's really happening. Well, sure enough, when we configured our global unicast address on this particular interface, automatically a link local address was created, and there it is. Yep, there it is. There's the link local address. Notice all this stuff is tentative, right? And that's because this interface is down. I don't have anything plugged into it on the other side. So all this is tentative for IPv6. I love it. But there it is, the link local address that got created automatically. Watch this. Let's go show run interface FA0/0 and let's remove our IPv6 address. So I'm going to go in and I'm going to remove it. And instead, let's check that. Do show IPv6 interface FA0/0. So no output results from this command because IPv6 isn't configured there at all now. But if I go to this interface and I just say IPv6 enable, please run IPv6, and I don't specify any addressing, sure enough, it configures itself with that link local address. Yeah, because in order for it to function on that particular segment, it needs that link local address, and the link local address is going to be used for a wide variety of purposes in IPv6. So, IPv6 addressing. You might have heard that not only is there no longer broadcasts to worry about, but you don't need to worry about DHCP anymore because devices can automatically configure their own v6 addresses. Well, this is partially true. First of all, understand that with v6 addressing, there is what we call a stateless auto configuration capability, and you can see it here. What happens is a device will come up on the link. Here's the happy little PC here. This device will come up and it will say, look, I want to find a local router that can give me the network portion of my IPv6 address. It is able to send this message on the link. Why? Because of the link local address that we just covered. Ah, I see. So that link local address is really important for these devices to be able to communicate. Here, the local router hears it and says, hey, no problem. Here's a router advertisement, and here is your prefix, Mr. or Mrs. PC. That PC takes that prefix and then automatically calculates its 64-bit host portion of the address. It does this, by the way, using its MAC address. That's right. It uses its MAC address in a process called the EUI 64 process. This is probably beyond the scope of CCNA a little bit, but that's okay if we go a smidge beyond. So it can automatically calculate its host portion once it gets its prefix from the local router, and voila. Oh, that's a terrible attempt at French there. I apologize to all of our French viewers. But what happens in the end result here? This PC has its prefix, it has its host portion of the address, and now it is ready and raring to go when it comes to communicating on the network. But wait a minute. What about all of the other information it needs, like default gateway information? What about all of the, like, its domain name, any special parameters? Well, we still are going to have DHCP in an IPv6 world, and you could call upon DHCP to give devices all that additional information that they need. This is called stateless DHCP in a v6 world. Sure, what it means by stateless is DHCP is in a very interesting position now. It really doesn't care about addresses on machines. It's not tracking that statefully anymore. That's being done automatically with that auto configuration process we looked at. What the DHCP for v6 can now do is just statelessly say, look, here's all the other information that you need. What an amazing world, the world of IPv6 addressing, and we covered in this video what you would need to know from a CCNA level about v6 addressing. Thank you so much for joining us here in part 2 of this 3-part series at the Cisco Learning Network on IPv6 addressing. I hope you are so excited. Actually, we're commenting on v6. This second part was on v6 addressing. I hope you're excited like I am for the 3rd part of this series, where we'll see how in the world are we going to get v6 implemented. I mean, we can't shut down the internet for a few hours while we make the cutover. So what kind of technologies exist for us to move to this exciting new world seamlessly? Thanks again, everyone, and I'll see you in part 3.